We are beginning our series with agent number 1, the autonomous decision-making agent. This is the first of 30 specialized agents we'll be building. Traditional automation relies on rigid, reactive scripting. These systems follow fixed if-then flows that ignore the broader situational context. When a rigid script collides with an edge case, like a system overload hitting a VIP user session, the logic breaks. The script lacks the situational awareness required to adapt. Modern AI engineering requires a foundational architecture capable of actual judgment and reasoning, moving beyond simple text parsing. The blueprint for this architecture is found in Imran Ahmad's book, 30 Agents Every AI Engineer Must Build. This is the core architecture that every subsequent agent inherits. It succeeds by folding environmental variables into a structured state, allowing the system to maintain awareness of its surroundings. The architecture of agent number 1 functions as a continuous cognitive loop. As this diagram shows, information flows from inputs through perception and cognition before resulting in an action. To see this in practice, consider a premium business client reporting a 2-day intermittent internet outage just 24 hours before a critical presentation. The process begins with perception. In this code block, the agent transforms raw input into a structured state, pairing the message with environmental context. It extracts metadata including the user's premium tier, current session data, and active system alerts from the network. Once the context is structured, the agent moves into the cognition phase. An LLM-powered core uses this data to calculate an escalation threshold and evaluate response strategies. Here is the mathematical logic behind that choice. The agent scores candidate strategies across weighted axes and uses an argmax function to identify and select the winning strategy. By following these 2 steps, the agent independently determines the severity of the crisis and maps out a resolution strategy without needing human intervention. Before irreversible actions occur, the chosen strategy passes a strict safety gate. This function validates the plan against financial limits and data access permissions. Clearance requires a confidence score above 0.8, adherence to credit limits, and a low customer impact risk. Approved strategies move to the action phase. The agent triggers a dependency-aware task tag, allowing it to execute several parallel nodes simultaneously to resolve the issue. For our premium client, the agent concurrently takes action. It schedules a priority technician, provides a mobile hotspot for backup, and upgrades their service tier. In the final learning phase, the agent measures the success of its actions. If the score falls below 0.7, it dynamically tunes its own escalation thresholds for the next iteration. The loop is now closed. The agent stabilized the client's connection and simultaneously improved its own baseline logic for future encounters. Contrast this resolution with the rigid decision trees we saw earlier. Situational awareness is the definitive difference between simple scripting and true autonomy. While agent number 1 provides the necessary foundation for these systems, it is specifically designed for immediate, single-step response loops. Curious, this raises a new question. How does an AI manage sprawling objectives that require days of systematic execution and complex resource coordination? That level of orchestration requires a shift from reactive decisions to proactive strategy. In the next episode, we'll look at agent number 2, the planning agent. Subscribe to the neuralsca channel to follow the rest of the series, and visit neuralsca for additional resources and case studies. You can find the full architectural blueprint and code for agent number 1 in Imran Ahmad's book, available now on Amazon and Pact.